pull it in just a little bit there. Okay. But also, I don't know, it's just kind of a different thing to get our heads wrapped around. So we're going to do 2 pages of notes today, and then we'll do 1 page tomorrow. And when I say 2 pages, it's really like not like 2 pages, but it's kind of 2 pages. All right, we're going to talk about indirect. So what does it mean to do something indirectly? Today to get out your notebooks, I directed you to get out your notebooks, right? What does it mean to direct you? Or to do something directly? Yeah, do it like straightforward, like I told you exactly what to do. If I wanted to indirectly tell you to take out your notebooks, what could I have done? Rather than saying it, what else could I do to show that I want you to take out your notebooks? Yeah, just start doing notes. And then eventually you guys would be like, oh, she's doing notes. We should probably also be doing notes, right? Something like that. Okay, so indirect means that we're not doing it directly. We're doing it kind of in a roundabout way. And that's why these proofs can be a little challenging, is because instead of proving it directly, which is what we've been doing, we're going to do it indirectly, which sounds crazy. Okay, and to do that, we're going to make a decision. By eliminating all other options. So if any of you have ever played the game Guess Who, you know, the thing where you like flip the, like, is your person have yellow hair? You say yes or no, right? If they say yes, then you flip everyone else that doesn't, and then no. So that's a game of like process by elimination. You're eliminating different people until you have like one person left up, and then you're like, oh, I know this is you. How do I know it's you? Because we went through all the other things, right? Okay, so this is another way to think of, we're going to be talking about mathematical opposites today. Now, mathematical opposites are different than our normal opposites. So normally when we think of opposite, what's the opposite of up? Down, inside. Whoa, do we have to go back to opposites? What's the opposite of inside? Outside, good. Opposite of, I don't know, left, right, all that good stuff. But in math, we have a lot of different other things that we need to prove. And so we need all the options. We need to list everything. So instead of just saying the opposite of red is, what would be the opposite of red? That depends on who you ask, right? Some people, when they say opposite of red, they're going to give you the complementary color, the color that's straight across on the color scale, which would be green. But some other people, when they give you opposite of red, they'd give you like a different code, things like that. Depends on how you're looking at it. So when we talk about mathematical opposites, this actually goes back to Heraclitus and Socrates and Plato and all of those actual like philosophers. It's insane. Okay, and those philosophers said that everything goes into 2 groups. Either yes, it is true, or everything else. And we can view the world into these 2 groups. Am I up doing that? So it's either in the true group or in the false group, and we can sort everything in our world into these 2 groups depending on what characteristic we're looking at. It's a pretty cool concept. I like the idea. It makes sense a lot to me in my brain. So when we talk about opposites, here are some opposites when we think about this mathematically. The opposite of up we want to describe everything that's not up. So what are some other directions than up? Down, what else? What's another direction than up or down? What did you say? Sideways. Like forward, right? Backward. We need all of those things into one group. And the way to name that group is we want everything except up. We want all the other directions. So a way to describe that is instead of saying up, we literally just say, you guys ready for this? Nope, because that's only one thing. We need all the options. We say not up. So the opposite of going up is going not up. Because we need every other option to be included here. It can't just be the two ways. It can't just be up and down. We need the sideways. We need forward, backwards, left, right. We need to include everything that's not up. And so we literally just call it not up. Okay. So what would be the opposite of white? How would I include all the colors that are opposite of white? Not white. Because what colors would be not white? Everything except white, yeah. So that's the goal. We need this everything else. So a lot of times we use that word not to do that. But we have to be really careful about that because sometimes we're given a not, like there is no school. If there's no school, what would be the opposite of a no school day? There is school. Or you'd say school is in session. I'm just going to say in school. So if we're given a not, to undo a not, we give us a yes on that. Okay. Last one, this one's more mathematical. If I say x is equal to 2, what would be the opposite of x is equal to 2? Good. X is not equal to 2. But really, there's only two options when we talk about equality. If things aren't equal, they're not the same number, what are the two ways we can compare that number? If it's not 2, it's either bigger than 2 or greater than 2. Or it could be if I'm thinking of a number and it's not 2, then it's either bigger than 2 or it's less than 2. So when you think of inequalities, there's only really 3 main inequalities. There's equals, greater than, and less than. That's going to take into play as we move on. We have one example with inequalities today. Okay, last word that we're going to talk about to build our base of what we're doing, and that's the word contradiction. Now, as teenagers, you guys should be really familiar with this word, contradiction, because you use it as a way to catch your parents, right, or catch your guardians, whoever you live with, your grandparents, your aunts, uncles, and saying, hey, but you just said this, or you said this, but now you're doing this, right? How many of you catch your teachers on their phone? Yeah, a lot of us, right? Not a lot of us, but some of us. Okay, that's a contradiction because teachers are telling you to put their phones away, and then what happens? They take their phones out. This is me indirectly trying to tell you a school rule right now for some of us that continuously are breaking it. See how I'm doing it? Teaching you indirectly about our indirect rules. Indirectly telling you a rule. Okay, if a contradiction means like you're catching something that they're going against or that they're doing. So contra is the prefix here. Contra means to go against or to do opposite of. And then diction means to say or what you said. So contradiction is going against what was stated. going against what was stated. So if your friends said tomorrow we are not wearing shorts, so you spend a long time waking up in the morning making sure that you're wearing something that's not shorts, you have pants that are clean, you wear pants to school, and then you show up to school and your friends are wearing shorts. Or one of your friends is, and you're like, yeah, but it's okay, 'cause it's me. Alright, so those of you that watch Mean Girls, anyone watch Mean Girls movie? Right? Which one? Either one. There's a part where you're not supposed to wear sweatpants so many days in a row, right? And then Regina wears sweatpants like 3 days in a row. And she's like, but it's just me. And they're like, no, this is still a rule. They kick her out. You guys know what I'm talking about? You don't want that one? Okay. We're going to glue this in probably on the next page because that's probably what you have for space for. Some of us need to get off the today because we have learning to do. And our test is next Thursday. This is a start today. Oh my goodness. Okay. 2, 3. Why is this so hard to pass out? I'm dying. Just kidding, I'm not. So as you glue this on the next page, you might want to glue it a little bit up. So I'm going to glue it just a little bit right at the very, very top of the next page. At the very, very top. Alright, here are our steps to writing an indirect proof. I printed this out because it was just a lot of work. Didn't want to make you guys write all this because it was too much. And then we're going to do one example, and then there's a really, really short practice today, so today's going to be a good day to get caught up on any other missing homework. Today's practice is super short. Alright, so first off, how to write an indirect proof. Before we start a proof, something that we need to know. Sorry, Slava, you still gluing in. Give you a second longer. Any proof, what is usually our first step? Even when we did like a 2-column proof, those of you that were with me, we did flow proof. So what was our first step always in a proof? Good, write the given. I didn't put room on this, so let's just write that above. The given. When we have the given, we know that the given is already true. So think of it kind of like a hypothetical. So if I was telling you like, oh, it snowed, when it snows 8 inches, we don't have school. The given is it snowed 8 inches. Did it actually snow 8 inches today? No. But we're imagining, okay, it snowed 8 inches, now what? Okay. So when we're given something, we have to assume that it's already true, that it already happened, or we're living like in this separate world where that's something that happens. Okay. So we're going to then identify the conclusion that we're asked to prove. In an if-then statement, which part is the conclusion? The if or the then? The then part, yeah. So if it's an if-then form, we need to make sure that's the then. Sometimes it just tells us to prove. Okay, and we're going to actually assume that this conclusion is false by stating the opposite is true. Okay, again, this is something that a lot of people will do when they argue. They'll be like, okay, let's just assume you're right for a second. And then they go through these hypotheticals of like, if you're right, then this is what you're saying, and then this is what you're saying, and then that would mean this, and that's why you're wrong. Okay, that's an indirect proof. You're proving why their logic isn't true. Okay, so step 2, after we identify that conclusion, we assume the opposite. Step 2, we're going to use logical reasoning. To show that the assumption leads to a contradiction. That what we originally said was true can't be true anymore. There's a contradiction. There's something going against it. Remember that hypothesis is the if part. So if you need to write that in as for the if. Sometimes our hypothesis just literally says given. Sometimes it's an if. Okay? Or sometimes it can be any other fact that leads to a contradiction that says, nope, that doesn't work. All right, and then our last step is we're going to point out that the assumption leads to a contradiction. So because since we assumed the opposite and we proved the opposite doesn't work, that means that the original conclusion must be true. So we're breaking it into those two groups, and we're saying, well, because it doesn't go into this group, it now belongs into this first group. So we're going into those two opposite groups. Again, it's kind of like that guess who game of saying, does your person have a hat on? Either yes or no. All right, we're going to do one example today. You guys are crushing this. I know this is not super, super exciting. You guys are crushing it. All right. So you have one example. I'm going to do it below this. If you glued this in on the last page, you might need to go to the next page. All right, last part for today. We're going to do a proof. If negative 2x plus 11 is less than 7, then x is greater than 2. So this is what we're going to prove indirectly. If we were doing a direct proof, this is where we would draw the line down the inequality and we'd solve for x. We'd get x by itself. That would be a direct proof, but we're doing indirect. So we need to prove the opposite can never work. Okay? So for step 1, we need to assume the opposite of our conclusion. Our conclusion is x is greater than 2. So what would be the opposite of x is greater than 2? What are our other options than x is greater than 2? We only have numbers in this whole world that are greater than 2. Good, less than 2. Thank you for saving us. Or equal to. Awesome, thank you. So step 1 is we're going to assume, and usually we start with that word assume, that x is less than 2 or x is equal to 2. So those are our other two options than x is greater than 2. X is less than 2 or x is equal to 2. So now we have to prove some logic, use some logic to show why this doesn't work. So I'm going to create a table with some x's. And when I do my table with x's, we said x has to be less than 2 or x has to be equal to 2. So what are some numbers that are less than 2? Ishmael, what's a number less than 2? Thank you. What's a number less than 2? Thanks. 0. Let's do one more. Negative what? 1. Okay, but we do need to include 2. That's why I skipped a line here, because x is equal to 2. That was an or there, so we need an x equal to 2. And then let's pick something that doesn't follow that order. Let's pick something really big in the negatives. Negative, give me a big number. 80? Now we said in our if that when I do negative 2 times x plus 11, we said that the answer has to be less than 7. So we're going to take our calculator. We could use Desmos if we want. I don't have my Desmos calculator back here, so I'm going to use this calculator here. So to start off with, what we're really doing here is we're saying negative 2 times something plus 11. So what's our first input? Negative 2 times 2. So I'm going to put that in my calculator. Negative 2 times 2 plus 11. And our answer is 7. Is 7 less than 7? No. Okay, now we're going to do the same thing, but instead of negative 2 times 2, we're going to do negative 2 times 1. We're just creating an input-output table. Okay, I'm not going to write it every time, so when we put in 1, we get out 9. Is 9 less than 7? Nope. Okay, let's put in 0. We put in 0, we get 11. Is 11 less than 7? Nope. Then we're going to put in negative 1. We get 13. What's going to keep happening as I go more and more negative? What's happening to my answers? Yeah, they're getting bigger and bigger and bigger. So at any point, is it going to all of a sudden be less than 7? No, we already had a number bigger than 7, and then they just keep getting more and more and more. So let's just test that with that theory of negative 80, something that's way bigger, just to make sure that the pattern continues. Yeah, when I put in negative 80, we get 171. Is 171 less than 7? No. But in our original statement, in our if-then, we said that when we do negative 2 times x plus 11, the answer has to be less than 7. Are any of our answers less than 7? No. And technically, we should keep testing and testing and testing. We should test decimals and fractions and all of this, but you're probably like, oh my gosh, Miss Morrell, that's too much. I agree. Okay, so step 3. This doesn't work because it had to be less than 7. This column was supposed to be a yes. But none of this column is a yes, and none of these numbers worked. So because none of these numbers work, that means our answers have to be on the other side of 2. They have to be greater than 2 in order to work. So we're going to write that out as a contradiction. We write it as a sentence. We're going to say when. And we're going to say what we assumed. What did we assume? When x is going back to step 1, when x is less than 2, or x was equal to 2, and we plug that into our negative 2x plus 11. Was negative 2x plus 11 less than 7? Did that work? No. So we're going to do a little slash through that less than sign. It did not work. Which that was the case. It was supposed to be that had to be it. So now we need to point out the contradiction. However, it must be that negative 2x plus 11 is less than 7. That's how the world was working in this case. Negative 2x plus 11 had to be less than 7. So since that wasn't the case, it didn't work, that's a contradiction, we went against what we said. Therefore, or we could say thus, or by contradiction, or in conclusion. What do you guys want to say? I always felt really like academic when I said therefore. Therefore, what must be the case? What was our original part that we were trying to prove? It didn't work when x was less than 2. It doesn't work when x is equal to 2. So what's the only other option? X must be greater than 2. So I know this seems like a little like out of craziness, and you're like, what the heck? I have no idea. Today's practice for this is just about the setup. It's going to ask you about how to, like the steps of how to set it up. And then it's going to ask you about those opposites. What's the opposite of red? Not red. What's the opposite of up? Not up. Things like that. It's not going to be any